Proof. What exactly is it? A proof is just some method of showing a mathematical statement is true. Don't know what a mathematical statement is? Then you'd better go check out the logic section first before coming back. There are many kinds of proofs and they all rely on some logical basis beneath them. Now I introduce some more notations that are commonly associated with proof. This is called the material conditional. We use this to link together two statements where the first intuitively indicates the second. You usually just read it if P then Q. This is called the material biconditional. You use this to link together two statements that intuitively indicate each other. You usually just read it P if and only if Q. These guys form the main bulk of all proofs, where we either suppose P is true to try and show that the statement Q is true, or you show two statements P and Q are equivalent. Let's prove a simple statement as an example. If n is an even integer, then n squared is an even integer. It seems pretty obvious, right? But for the sake of an example, we'll treat it like any other more difficult question. The first step in any proof is to assume that the supposition, that is the thing just after the if, is true. Now the next thing is that you need to use the definition of an even integer. Definitions are a very important part of university study, so you'd better get used to them. This would be my definition for an even integer. An integer n is an even integer if there exists an integer m such that n equals 2m. Just writing so n equals 2m would not be sufficient at a university level. The final step is to use the definition to get to the desired result. Since n equals 2m, n squared equals 2m in brackets squared equals 2 times 2m squared. So by the definition of an even number, n squared is even. For an actual exam or coursework type answer for this question, I might write something like this. Let n be an even integer, then there exists an integer m such that n equals 2m. This implies n squared equals 2 times 2m squared, and this implies that n squared is even. This arrow with double lines, which is very important, is called implication, and it's just a shortcut for writing implies. Confusion warning. Implies and material conditional are different. Implies is a shortcut for the word implies. Material conditional means the material conditional, as in the logical connective. Super confusion warning. If and only if and material biconditional are different. If and only if is a shortcut for the phrase if and only if. Material biconditional means the logical connective material biconditional. Even though you usually shorten it also to if and only if, they're still different. Also, don't be scared by the amount of words you need to write. It may have been daunting on the previous page, but that was really nothing compared to some proofs. Oftentimes, a coursework answer for me will just be a bunch of paragraphs, and not really much maths at all. I'll briefly mention a few methods used to prove things here. Note that this is brief, there's not much detail, and there's definitely more ways to prove things than what I'm showing here. First, we'll start with the simplest, direct proof. This is just what we did before. Simple implications that take you from the supposition to the desired result. Next is proof by contradiction. First, you suppose that the statement you want to prove is false. Then you show that it leads to some kind of nonsense, so you can deduce that the original statement must not be false and is therefore true. For example, we can use this to prove that the square root of 2 is an irrational number. First, suppose it's a rational number, show that it can't have an irreducible rational form, and therefore it must be an irrational number. Next is proof by contrapositive. Use this logical equivalence. P implies Q is equivalent to not Q implies not P, which is called the contrapositive of P implies Q. For example, you could prove this. Let n be an integer. Prove that if n squared is odd, then n is odd. The contrapositive of the statement is just if n is an even integer, then n squared is an even integer, which we've already done. Next is proof by cases. Here you split the proof into several mini-proofs, which when combined make up the entire original proof, but individually are considerably easier. For example, many proofs about the integers can be split into even and odd cases, such as let n be an integer, prove n squared plus 3n is an even integer. Lastly is disproof via a counterexample. In an exam or coursework you may be asked to disprove something, but it's more likely you'll be asked something like, is this true? Show a proof or counterexample. You must give a specific counterexample to the statement, otherwise you will not get any marks. For example, consider this. Let x and y be real numbers. Show that xy equals 0 for any x and y is a false statement. If x and y are non-zero, then xy is non-zero. This is a terrible counterexample because it is not a specific counterexample. Take x equal 1 and y equal 1, then xy equals 1 not equal to 0. This is a good counterexample because x equals 1 and y equals 1 is a specific counterexample to the statement. Now a few general tips. If you want to prove a statement P or Q is true, it is equivalent to prove not P implies Q or not Q implies P is true. They are usually less work. In many cases, it is useful to simply use the definitions that are relevant and nothing too fancy is otherwise needed, so try simple things first before anything complex. The odds of needing to Google some obscure formula or theorem is very low for your coursework. Typically, if something seems too daunting to try and prove directly or any other way, contradiction is normally the best bet. Remember, for an if and only if statement, you must prove both directions of implication to prove the entire statement. And remember that you can use the contrapositive as part of this. That's all for proof here, but this is just a basic overview. To test your understanding, you can go try the tests, or you can move on to another section. Thanks for watching.